Alrighty, hello everybody, and welcome back to Psychology 2E with OpenStax. This is the OpenStax textbook, and we're going to continue going on from Chapter 1 to Chapter 2, and in this chapter we'll be going through psychological research. My name is Prescott, and I'm here with Succinct Psychology, and I'll be walking you through this today. So, without further ado, let's get going. So, starting off, we got this nice little picture. How does television content impact children's behavior? You got the credit. So we're kind of going to be going through how people research this kind of thing. How does television content impact children's behavior? So we'll go through how researchers determine that. So starting off, why is research important? So at one time in history, people believed the earth was flat and that mental illnesses were caused by possession, believe it or not. People can be very wrong in their ideas about the world when they do not rely on evidence to support their claims. Research is a mandatory process in validating claims. So scientific research is empirical, which means it is grounded in objective, tangible evidence that can be observed time and time again, regardless of who is observing. Without research, we would only have intuition and groundless assumptions, which wouldn't be good for determining things at all. Through research, we are able to prove certain ideas through study and testing. So psychology is a science, therefore research is required to not only further investigate something, but provide verification and support of the findings. So here we have a nice picture of a human skull. Some of our ancestors across the world and over the centuries believed that trephination, I don't know if I'm pronouncing that right, or the practice of making a hole in the skull, as shown here, see that big old hole there, allowed evil spirits to leave the body, thus curing mental illness and other disorders, which we now know isn't a way to cure mental illness and other disorders. It's not a good thing to have a giant hole in your skull. So, use of research information. Advertising campaigns often claim to be based on scientific evidence, quote, quote, when in reality, it is based off of belief. So thinking critically about claims, what is the expertise of the person making the claim? What might they gain if the claim is valid? Does the claim seem justified given the evidence? And what do other researchers think of the claims or the claim? So this is how you think critically about claims in research. So the process of scientific research, inductive versus deductive reasoning. So deductive reasoning is results are predicted based on a general premise. All living things require energy to survive. That's your premise. Ducks are living things, therefore ducks require energy to survive. Conclusion. So it's just the general premise that all living things need energy to survive. Ducks are living things, so therefore they require energy to survive. That's your conclusion. Inductive reasoning are conclusions are drawn from your observations. So, example, you see many fruit growing on trees and therefore assume all fruit grow on trees. So here, instead of just, it's a general premise that everybody knows, it's you see the fruits on the trees, therefore all fruits must grow trees. So, walking through the process. So 1, scientists form ideas, so theories or hypotheses, through deductive reasoning. Again, that's based on general premises. Step 2, hypotheses are then tested through empirical observations, and scientists form conclusions through inductive reasoning. So that's making observations. 3, these conclusions lead to new theories and hypotheses or more broad generalizations. So here we have a nice little graph. So you start off hypotheses or general premise, use your inductive reasoning to come up with empirical observations, and then use your deductive reasoning to form further hypotheses or general premises. So psychological research relies on both inductive and deductive reasoning. You need both in order to kind of effectively research. You can't just only use deductive reasoning or only use inductive reasoning. Continuing on, so now we come to the scientific method. So scientists use inductive reasoning to form theories, which then generate hypotheses. Theory is a well-developed set of ideas that propose an explanation for observed phenomena. And a hypothesis, or hypotheses, I might vary in my pronunciation. So hypotheses are a tentative and testable statement or a prediction about the relationship between two or more variables. So hypotheses predicts how the world will behave if the theory is correct, and usually they're an if-then statement, and they are falsifiable or capable of being shown to be incorrect. So here we have another nice little flow chart kind of. So come up with your theory, which is your well-developed set of ideas that propose an explanation for observed phenomena. You use the theory to form hypotheses or a tentative and testable statement about the relationship between two or more variables. And then you design a study to test the hypotheses. So you conduct research, perform the research, which leads to you making observations, which you then, so you observe what came of your research to then create or modify. So create a new theory or modify your existing theory. So that's kind of how the scientific method works. Here we have a nice picture, some pictures here. So many of the specifics of Freud's theories, here's Freud right here, such as, and here's another picture, his division of the mind into ID, ego, and superego. And if you guys remember from the previous videos, we went over the ID, ego, and superego. So if you guys want to know more about that, then check back on those videos. So his division of the mind into id, ego, and superego have fallen out of favor in recent decades because they are not falsifiable. They can't be proven wrong. In broader strokes, his views set the stage for much of psychological thinking today, such as the unconscious nature of the majority of psychological processes. So, going on, now we're going to go over approaches to research. So, briefly going over, we have clinical or case studies, naturalistic observation, surveys, archival research, and longitudinal and cross-sectional research. So first off, we have clinical or case studies. So clinical or case studies focuses on one individual. The studied individual is typically in an extreme or unique psychological circumstance that differentiates them for the general public. So case studies allow for a lot of insight into a case, but they are difficult to generalize results to a larger population because they're focusing on one specific individual who has a unique psychological circumstance that differentiates them. So you can't really generalize the findings in a case study to your general population. An example here is Jeannie. So Jeannie was studied by psychologists after she was found at age 13 having suffered severe abuse and social isolation. Psychologists were interested in the effects social isolation had on her development. And again, they can't generalize that to the general population because she's a special case. Hence, case studies. Oops. Continuing on. So this is naturalistic observation or behavior. So observation of behavior in its natural setting, naturalistic. Naturalistic behavior is generally hidden under scrutiny or observation. So, for example, seeing a police car behind you would probably affect your driving behavior. To study the most accurate and genuine behaviors, naturalistic observation is proven most effective. Through naturalistic observations, any feelings of performance or anxiety of the studied individuals is eliminated. So, and here we go further into detail, observer bias is when observations may be skewed to align with observer expectations. And I apologize, this picture is kind of blocking it out. We didn't make these slides, we just got them. So establishment of clear criteria to observe should help eliminate observer bias. So again, seeing a police car probably affect your driving behavior. That's not naturalistic observation. If a cop's driving behind you, you're probably, at least me personally, I drive much more carefully because I don't want to get pulled over, get a ticket or anything, which causes observer bias. So you're aware that somebody's watching you, so you act differently. That's observer bias. So here we go, Jane Goodall and some chimpanzees. So Jane Goodall made a career of conducting naturalistic observations of chimpanzee behavior. So she didn't interfere. They weren't aware she was watching them, so they acted normally. Whereas if she had been present and they were aware that she was watching them, they might have acted differently, which isn't a naturalistic observation because she's causing observer bias. So going on, we have surveys, which I'm sure plenty of you have done at least one of. So a survey is a list of questions that can be delivered in many ways, so through paper and pencil, electronically, or verbally. Surveys can be used to gather a large amount of data from a sample or a subset of individuals from a larger population. Surveys can be administered in a number of ways, including electronically administered research, like the survey shown here. So here, you got a little survey, and I'm sure you guys have gotten offered electronic surveys through emails or your school that you're taking classes at. They'll, at least for my school, FSU, they'll be like, at the end of each end of each semester, you'll have a little survey about how much you like the class and whatnot. That's the school trying to gather information by asking everybody a lot of basic questions electronically. Continuing on, we have archival research, which uses past records or data sets to answer various research questions or to search for interesting patterns or relationships. So here we have a little figure. A researcher doing archival research examines records, whether archived as a hard copy, seen here, or electronically, seen here. So basically using pretty straightforward. You're using past records or data sets to answer your research questions or to search for patterns in those relationships. Alrighty. So now we have longitudinal and cross-sectional research. So cross-sectional research compares multiple segments of a population at a single time, such as different age groups. Longitudinal are studies in which the same group of individuals is surveyed or measured repeatedly over an extended period of time. Researchers often expect some participants to drop out, particularly in this type of study, and therefore often initially recruit a lot of participants because many of these studies suffer from attrition, which is the reduction in number of research participants as some drop out of the study over time. So longitudinal research, like the CPS-3, help us to better understand how smoking is associated with cancer and other diseases. So just to break it down further, longitudinal would be like studying child development. Okay, we're going to start studying this group of individuals from the time they're a year old to the time they're 10 years old. They're studying the same group over an extended period of time, whereas cross-sectional, you might compare multiple groups, age groups, at a single time. So, okay, how do kids this age group act and compared to kids in this age group in this population? And finally, almost, is correlational research. So correlation is a relationship between two or more variables. When two variables are correlated, one variable changes as the other does. So correlation coefficient is a number from -1 to 0.1, indicating the strength and direction of the relationship between variables, and is usually represented by R. A positive correlation is when two variables change in the same direction, both becoming either larger or smaller. See here, positive correlation. A negative correlation is two variables change in different directions, with one becoming larger as the other becomes smaller. A negative correlation is not the same thing as no correlation. So here we have a negative correlation. So as hours of sleep go up or down, I guess in this situation, your tiredness. So they're going opposite directions. It doesn't mean that there's no correlation. Here's no correlation. There's just no correlation between hours of sleep and shoe size. So, and then correlation coefficient. So if it's a -1 correlation, it's a very weak correlation. So it wouldn't be the sequence of dots wouldn't be as tight knit. They'd be more spread out. It'd still be positive. It would just be harder to tell because they're more spread out. Whereas closer to 1 that they are, like these ones seem to be, they're tighter together. So we're going to stop here for today. We'll go further into correlation does not indicate causation and continue the lesson in the next video. Again, my name is Prescott. I'm here with Psychcinct Psychology and hope to see you guys next time and have a great day.